intended for educational and informational purposes only. All drone operations shown are performed by licensed remote pilots in compliance with the Directorate General of Civil Aviation (DGCA), India, and other applicable regulations. The viewers are advised to strictly follow all local laws and aviation guidelines. The creator of this video assumes no responsibility or liability for any misuse or violation arising from the information provided. Always fly responsibly, respect privacy, safety zones, and no-fly zones. Fly smart, fly safe.
Hey there, drone pilots. Welcome to Module 6 of the FreeSky project. Today, we are diving into one of the most essential but often overlooked parts of drone mastery, understanding your drone's anatomy and taking good care of it. This isn't just about flying, it's about flying safely, smartly, and sustainably. Let's get started. Learning objectives. By the end of this session, you'll know what makes up a drone from the inside out, how to maintain it before and after flights, and how to catch issues before they turn into expensive problems. What is a UAS? UAS stands for Unmanned Aircraft System. It's not just the drone in the sky. It includes the aircraft, aka your drone, ground control system where you manage everything, remote pilot station, that's you, payload like cameras or sprayers, communication links, power system. Think of it like a mini aircraft operation, not just a toy. Core components of a drone. Here's your drone's brain, heart, and limbs. Frame holds everything together, like the skeleton. Brushless motors spin propellers that give lift. ESC electronic speed controller. Think of it as a translator between your command and the motor. Fly controller. The brain handles stability using GPS and IMU. GPS module for location, return to home, and altitude lock. IMU, inertial measurement unit, detects drone's tilt, pitch, and roll. Propellers, converts motor speed into actual movement. Battery powers everything. Flight time depends on it. Payload, cameras, LiDAR, etc. Bonus tip: learn how to swap parts. Quick fixes can save a ruined shoe today. Power systems and battery care. This one is critical. Most drone accidents happen due to poor battery care. Usually poor batteries, 2S to 6As. Keep voltage above 3.3 volts per se or say goodbye to your battery life. Always store at 50% if you're not flying immediately. Never use puffy or swollen batteries. They're dangerous. Use fireproof lipo-safe bags. Bonus tip: always carry a battery checker with you. You'll thank me when flying in remote locations. Alright, let's talk about the sensors of your drone, the sensors that help it feel, see, and respond to the world around it. Just like we rely on our eyes, ears, and sense of balance, drones rely on sensors to maintain stability, gather data, and fly safely, even in tricky conditions. Let's break down the key ones. 1. Gyroscope. This tiny but mighty sensor measures angular velocity. In simpler words, it tells the drone how fast it's rotating around its axis. Without it, your drone would be wobbling all over the place. Bonus tip: a faulty gyro can make your drone behave erratically, so always recalibrate after transport or crashes. 2. Accelerometer. This works hand in hand with the gyroscope and tells the drone its orientation and movement. It knows whether you're going up, down, forward, or sideways. It's how the drone knows it's tilting or accelerating, crucial for smooth hovering. 3. Magnetometer. This acts like a digital compass, helping the drone understand its direction relative to magnetic north. It's vital for GPS navigation and for holding a steady heading. Pro tip: always calibrate your compass away from metal structures, vehicles, or your phone. Interference is real. 4. Barometer. This sensor measures air pressure to estimate altitude. Why does this matter? Because the drone uses it to hover at a stable height, especially important for automated flights or altitude hold. Lower pressure equals higher altitude. Pretty neat, right? 5. GPS module. This one is familiar. GPS gives the drone its exact location, speed, and altitude using satellite data. It enables return to home, waypoint missions, and geofencing. Always wait for a strong GPS lock before takeoff, ideally 6 to 8 satellites minimum. Fewer satellites equals risky flight. 6. Vision and obstacle sensors. These are usually forward, downward, or upward facing cameras or air sensors that detect ground patterns or obstacles. They help with precise landing, indoor flight, and collision avoidance. Think of them as the drone's eyes. 7. Temperature and battery sensors. These monitor the drone's internal temperatures and battery voltage in real time. Overheating can cause mid-air shutdown, so these sensors are your safety net. So to sum it up, your drone isn't just flying blindly. It's constantly gathering data from all these sensors every millisecond to keep your flight safe, stable, and smart. Keep your sensors calibrated, know how they work, and your flights will be smoother and safer than ever. Propulsion system tips. Your propellers and motors are literally what keep you in the air. Always check for cracks, chips, or loose screws. Replace damaged props, no questions asked. Clean your motors with compressed air. Avoid flying in dusty/sandy areas when possible. Bonus tip: carry a prop nut spanner in your field kit. Pre-flight and post-flight checks. Your flight safety depends on this. Before each flight, battery charge above 90%. Props are tight and undamaged. Calibrate comps and GPS. Payload secure. Weather and airspace clearance checked. After each flight, power down drone safely. Inspect for physical damage. Log your flight time and any anomalies. Recharge or store batteries properly. Pro tip: print these checklists and laminate them. Field ops become way smoother. Maintenance schedule. Inspect props and log battery cycles after every flight. Update firmware and calibrate sensors weekly. Do a full drone health check monthly. Bonus tip: keep a digital and physical logbook for DGCA compliance. Let's face it, even the best drones can run into trouble. But the good news is, most common issues have quick fixes, if you know what to look for. Here are some frequent problems you might run into while flying and how to handle them like a pro. Issue: GPS loss. Cause: you might be under trees, near power lines, or something's interfering with your signal. Fix: move to a clear location, give it a few seconds to reconnect, and if needed recalibrate that comps. Bonus tip: always wait for at least 6 satellite locks before takeoff. Issue: motor stuck. Cause: could be a debris jam, or worse, a faulty ESC, that's the motor controller. Fix: power down. Gently remove any dirt or hair tangled in the motor. Check the ESC wires for burns or loose connections. Always carry a soft brush or tweezers, lifesavers in the field. Issue: drone drifting mid-flight. Cause: windy day, or maybe your IMU isn't calibrated right. Fix: recalibrate the IMU. And before your next flight, check your weather app. Gusty winds can mess with stability more than you think. Issue: gimbal shaking or vibrating. Cause: usually it's loose mounting, or your propellers are unbalanced. Fix: gently tighten all gimbal screws and make sure the props aren't bent or chipped. Unbalanced props cause invisible vibrations that ruin your footage. Pro tip: always carry a field repair kit. Here's what we recommend in your drone first aid box. Spare propellers. You will break a few tiny screwdrivers, Phillips and flat zip ties for quick wire fixes, contact cleaner for ports and connectors, a backup USB cable because losing one mid-shoot is the worst. A prepared pilot is a confident pilot. Whether you're flying a quick mission or a full shoot, small problems shouldn't crash your day. Be ready, stay calm, and fly smart. To summarize: know your drone inside out, respect the battery, it's your lifeline. Pre- and post-flight checks should become a ritual. Document everything for compliance and troubleshooting, and above all, fly safe, fly smart, and fly with purpose. Alright pilot, it's time for a quick quiz. Let's see if you've been paying attention. Question 1. What component controls the drone's stability in flight? Think, balance, orientation, Answer: that's right. It's the flight controller working together with the IMU, the inertial measurement unit. They're like your drone's internal gyroscope and balance coach. Question 2. What's the ideal battery storage charge level? Give it a second. Answer: the sweet spot is 50 to 60% charge, not full, not empty. This keeps your LiPo batteries healthy and extends their lifespan. Bonus tip: use your smart charger storage mode to make life easier. Question 3. What tool is used to check or tighten propellers safely? You've seen it in your toolkit. Answer: it's a prop nut spanner. Never fly with loose props. It's like driving with a flat tire. Always keep one in your field repair kit. Great job! Whether you need it or learned something new, you're one step closer to becoming a safer, smarter drone pilot. Keep going, you've got this. Thanks for watching. If you enjoyed this video, give it a thumbs up, share it with your fellow drone enthusiasts, and don't forget to subscribe to the FreeSky project for more amazing content from the skies of India. Hit that bell so you never miss a flight.